Endorphin supports import of animation data in a large variety of formats. In this tutorial, we're going to import an FBX file of a person running holding a gun. We're then going to adapt that animation using the tools available in Endorphin under simulation. So let's start a fresh Endorphin scene and delete the default character. And now, either using the button on the main toolbar or from the character menu, add a new character. We want to select the Naturalmotion 2 character under simulation characters in the add character dialog. If it doesn't appear in the list immediately, you may need to navigate to the Resources, Tutorials, Tutorial 7 directory, which is inside your installation directory. So select Naturalmotion 2 and click OK. Now select the character in the timeline and from the File menu choose Import. In the File browser, navigate to Tutorial 7 Importing and Modifying Animation, which is inside your installation directory, and select the Run with Gun FBX file, making sure that you do have file of types animation selected. Click Open. Now in the Select Root Node for Import section on the right hand side of the Import dialog, select the Hips node. This hierarchy represents the hierarchy from within the FBX, and we want to import from the hips down. Now move to the Automotion Transfer section, and in here we can specify the details of a reference character we're going to want to use to help transfer the motion from the FBX onto our simulation character. So check the Source Reference Character box and browse to open the Reference Character dialog, and from there under Reference Characters select Naturalmotion 2. Again, you may have to browse to the Resources, Tutorials, Tutorial 7 directory in order to pick that up. Click OK. This reference character contains a mapping of the joint names between those contained in the FBX and those on our simulation character, and that's what's used to map the motion across. Now move down to the General section and check Include Parent Transforms. This simply means that any world space transformations that happen inside the FBX will be brought across as well. Now before we leave the import dialog, just take a look at the animation section. In here you have the option to create an animation event when the animation is imported, and also to create simulation events. And we'll look at simulation events a bit later on, but for the time being leave those both checked and leave the rest of the values in the import dialog at their default and click OK. And now that animation will be brought in and the motion transferred onto our simulation character using the reference character we specified. And now in the timeline you can see there's an animation event that's been laid down and 2 simulation events, since we specified that we wanted all of those to be created on import. So now if we set the scene up so that we can see the character from some distance and then simulate, you can see that the character runs across the ground plane and then falls to the floor. I'm going to scroll back and notice that the character is greyed out at this stage. His colour is completely grey. This means that he won't be affected by any simulation, that all of his motion is being driven directly by this animation event, nor will he affect the environment in any way, nor affect any other simulation occurring in the scene. So this character is being driven entirely by the animation contained in the FBX we imported. There are other ways to have the animation drive a character, both partially and completely. We'll touch on those in other tutorials. These simulation events that have been loaded in with the animation determine the level of simulation at the point that they occur. So the first one, if we select it and move to its property view, we can see that the current simulation mode is no simulation. So at frame 0, when the animation event begins, the character is completely non-simulated. Then this last one switches the simulation level to full simulation. So at this point, the character can be affected by all the simulation tools within Endorphin. Let's take this last simulation event and move it to frame 95. Now if we simulate, you'll see that the character will be affected by the animation until frame 95 when he just falls to the floor under gravity. And that transition is completely seamless from greyed imported animation driven motion to full simulation when the blue and grey colour returns to our character. So in this example we're going to simulate the character being blasted by an explosion. So we'll remove the existing animation and create a force event just at about frame 95 by right clicking in the character's timeline. Now let's move in and select all of the spine body parts as the selection set for this force event. Click select in its property view, control left click on all the spine body parts, including the pelvis. And now these are the sections of the character that will be affected by this force. Now moving over to the force events property view, we want to increase the strength of this force to make it a big blast from 12 to 30. Now let's change the elevation value from 90 also to 30, and you'll see that the force arrow now is pointing upwards, and this is going to help us to simulate blasting the character into the air. And finally we'll change the rotation value to -3 just to change the angle of the force and therefore our simulated blast on the character and give it a bit more interest. So now we can move around in the viewport to get a good view of the animation, and as we do that you'll see in the background there's a visualization of the animation event. If I go down to the animation event on the timeline and select it, then move over to its property view, you can see that I can turn that visualization on and off. And that gives you a visual indication of the animation held within the animation event, even when it's not being applied to the character. So now let's move back a little and simulate. You can see the character runs across, is hit by the force and is blasted into the air and onto the floor. But if we now play that animation back, you can see that after the force is hit and the character is in simulation, he's lifeless and ragdoll-like. So let's now enhance that by adding some behaviours. So let's right-click in the character's timeline and create a behaviour event. We'll move that along to start at frame 95, exactly where the force is, and moving up to its property view, we can change it to a writhe 2.0. Let's now move down to the velocity value in its property view and change the value from -0.6 to -0.8, and that will affect the speed and direction of the character's movements as he writhes. Now let's simulate again. The character runs, is hit by the force, and this time as he flies through the air he's writhing. Now let's set the end of the writhe behaviour to finish at frame 140. Now we'll create another behaviour, start that one at frame 140 and make this one a catch fall 2.0. And now we want to turn off predict ground height. With this property enabled, the character will assume the height of the ground is the height of his lowest foot. If we turn it off, we can set the ground height explicitly using the ground height value below, and this is now the ground height that the character will use in the catch fall behaviour. Now if we simulate again, the character runs, is blasted by the explosion, flies into the air and reaches for the ground as he lands, but the reach is actually not very convincing. Let's just play that animation back and have another look. So he runs, he gets blasted, writhes and tries to reach for the ground, but it's really not working very well at the moment. So let's add another behaviour by right clicking in the timeline, create behaviour event, and we want to change the endpoint of the catch fall behaviour to frame 166. This is around the point where the character collides with the ground. And then we'll start the next behaviour at that endpoint, and we'll make this one a body fetal. Now when we simulate, the character runs, blasted by the explosion, writhes, reaches, and as he hits the ground he falls into a body fetal. So you can begin to see how an animation can be imported from an external source, then modified and extended to produce an enhanced animation. And of course by changing, for example, the rotation of the force and the timing of some of the events, you can get a completely different result altogether.